Hi everyone, this video is the presentation of the solution to the last example on rotated vessels. And here is the problem. An open hemispherical tank with base uppermost and horizontal is 2 meters across the top and full of water. It is rotated about its vertical axis. Determine the amount of water in liters spilled or that will be left in the tank for the following conditions. The angular speed is 30 revolutions per minute. The vortex of the resulting surface coincides with the bottom of the tank, and the angular speed is 60 rpm. So that's the information for number 1. H1 equals 0.0005589 omega square 30 square radius 1 square. So H1 is 0.503 meter, which is less than 1. Therefore, the parabolic surface will just be above the bottom. And therefore, the volume that will be left is volume of hemisphere minus volume of paraboloid of revolution with one base. So, volume left is equal to hemisphere 2/3 pi 1 cube minus pi over 2 times 1 square times 0.503 times 1000 to convert the volume left in liters. So, volume left is 1304 liters. For the second one, the vortex of the resulting surface coincides with the bottom, so that's it. So it's just volume of hemisphere minus volume of paraboloid of single base of depth 1 meter. So volume left is equal to quantity 2/3 pi 1 cube minus pi over 2 1 square times 1 and times 1000. So volume left is 523.6 liters. And finally, for the third, angular speed is 60 rpm, so h3 equals 0.0005589, 60 square, 1 square. And this time, h3 is 2.012 meters, which is greater than 1, so the vortex goes beyond the bottom of the tank, as shown. So this is the volume left part, so we need to determine the equation of the circle and this parabola here. Let's consider the vortex of the parabolic surface as the origin, and this is 2.012 meter. Then the intersection between the parabolic surface and the hemisphere is here. Then we call this point x comma y, so that's the origin. The location of the center of the circle hemisphere, or this semicircle here, the center is here, would be 0, 2.012, because this I denoted this as the origin. And we will call that x comma y, wherein this is y and that is x. So the equation of a circle is x minus 0, x minus center quantity square plus y minus 2.012 quantity square equals radius square. So x minus 0 square plus y minus 2.012 square equals 1 square. While for the parabola by squared property, y as to x square equals 2.012 as to 1 square. So therefore, x square is y over 2.012. Then let's substitute that into this equation here for x square. So y over 2.012 plus quantity y minus 2.012 square equals 1. Simplifying this equation, y square minus 3.527y plus 3.048 equals 0, giving two roots of y, 1.515 meters, and of course 2.012, because this is the other intersection, y is 2.012. So we just consider y equals 1.515, which corresponds to this value here, so that we can solve for this x, which is expected less than 1. So x squared equals 1.515 over 2.012, extract the square root. So x is plus minus 0.8677, so that's negative 0.8677, and that's positive 0.8677. So 0.8677, then let's solve for y, which is 1.515. Therefore, we have here the height here, 2.012 minus 1.515, the height of this paraboloid of revolution with two bases, 0.497 meter. And this portion below this circular section is uh, spherical segment of one base, and this height is 1 minus 0.497, so that's 0.503 meter. So this volume here represents final volume of air, which is volume of paraboloid of revolution with two bases, radii 1 and 0.8677 and height 0.497 meter, and volume of spherical segment of one base of height 0.503 and the radius of the hemisphere 1. So volume of air final equals volume of paraboloid with two bases plus volume of spherical segment. For the paraboloid with two bases, pi over 2, quantity 1 square plus 0.8677 square, quantity times 0.497. Then for the spherical segment of one base, pi 8 square over 3, pi 0.503 square over 3, quantity 3 times radius, 3 times 1 minus 0.503. So pi over 3.503 square, quantity 3 times 1 minus 0.503. Combining, volume of air final is 2.030 cubic meters. Therefore, the volume of water left is volume of hemisphere minus volume of air final. 2/3 pi 1 cube for hemisphere, then minus 2.03 times 1000. So the final volume that is left in the tank in liters is 64.4 liters. So that's it, and take note, this is the last example.